Yeah, welcome back to our online classes. Where, if you can remember, last week we talked about factors affecting the performance of solar system, which I mentioned are three. One, we have high temperature. Two, we have shading. Number three, we have dirt and dust. And here we are today. Yeah, welcome back. All right. Basically, this is 200-watt solar panel. As you can see, this is a nameplate of it. Is 250-watt solar panel. We have all the parameters available. Output tolerance, IMP, that is maximum power current. We have BMP, we have short circuit current and BOC. Okay, we are going to see what will happen if we are going to measure the panel first to see its parameters, and then we apply this aforementioned hindrance, that is the blockage of a cell, and shading, and so also dirt and dust, to see how they will affect the performance of this very solar panel. Follow me. Now, this is the measuring instrument. As if you can remember the other time, I mentioned we have multimeter, we have clamp meter, and we have solar meter. Okay, so now for us to get the short circuit current, how do we do? We shorten these terminals. We have positive polarity and we have negative polarity, like this. Okay, so now we will have the short circuit current. For now, we have the short circuit current. So basically, we are going to measure the short circuit current for now, and later on, we are going to see how it will reflect on our clamp meter. This is, as you can see, is just 0.005. This 0.005 is just a tolerance. Now we are going to clamp it. We have 1.05. Now let me allow the funnel to face the direction of the sun. Are you seeing it? It will keep increasing, to keep increasing, increasing. All right, this is at 5:30, and you all know that we ought to orient our panel to face the direction of the sun for us to get the maximum power, maximum current, and whereas the open circuit voltage, of course, you all know, irrespective of the position we place our solar panel, we will get close to the maximum. But for the what? IMP, or short circuit current, we're going to get, the more the intensity, the higher the current. The lesser the intensity, the lesser the current. Okay, now let me place this solar meter. Okay, okay, before placing the solar meter, let us use the multimeter to measure the open circuit voltage. Initially, it is rated 46.22, right? Open circuit voltage 42. So let us see. Okay, can you see it? We have 43.76, which means it has, if you look at the tolerance here, plus or minus 5%, meaning you can have either above this system voltage, or you can have below. The tolerance is plus or minus. So now, do you see, we only have little increase, right? So irrespective of whether we tilted our panel to face the direction of the sun, or maybe we intend to take it upside down, we're going to get close to maximum. Look at, close to the maximum power of maximum voltage. Okay, so now we'll use our, we are going to use our solar meter to ascertain the aforementioned parameters. Okay, okay, we are having open circuit voltage alone, right? So I'm going to run the test. It is completed. It is completed. Okay, So you can see we have the BMP, we have the IMP, we have the what do you call maximum power, and then look at the BOC and ISC. Of course, when we measure our current using what do you call it, clamp meter, we obtain 3.3 something, right? Okay, so now this meter will tell you or will give us all the parameters at once to give us the maximum power, to give us the BMP, IMP, BOC, ISC within one single test. Okay, now we are going to see this effect. How are they affecting the performance of solar panels? Now we are going to start with dust. Pause. Okay, here we are. Now we applied sand and little dust to what? To disturb the surface of this solar panel. Now we measure the parameter. We run a test to see how they affect actual intensity or actual absorption of what? Of our solar intensity or solar system. All right, we're going to run a test. Okay, it is completed. What do we have? BMP 38.3. IMP is now 0.1. Initially, we were getting 3 point something because the intensity is going down. This is past 5 to 6. All right. The VOC, of course, we all know we're going to get close to the maximum, which is 39.6, and the IS is 0.2. So now, okay. So now we are going to, we still have a little dust or dirt on the surface of this solar panel. Let us run another test and see how it will affect, whether it will increase or decrease. Okay, the test is what? Completed. Of course, you see, if you can remember, during our introductory part, I explained that blocking of a cell will lead to what? Reduction of almost 25% of what the panel is what is generating. Now, initially we were getting 3.3, 3.4 at this very late hour. And now, even though we remove all the dust, but look at it, we still have some portion of dirt. And that is why after we run our test, the current is still what? Minimal. So which means for us to get the maximum parameters, which means this surface need to be what? Cleaned to achieve better performance or better output. Okay, so now we are going to use water to clean up this solar panel and then remeasure to ascertain what we have just concluded now. Okay, so now we're going to clean up this solar panel. And okay, mind you, during the maintenance on solar panel, make sure you use the what? Recommended procedure. Don't use maybe a hard rocks or maybe something that can scratch the surface of this solar panel, because it's just a glass. If I scratch these glasses, I cannot be able to see well, right? So the same thing with the solar panel. If you use something that is very hard to clean its surface, which means you are now trying to bring disturbance that will what? Make the panel not to perform very well. So now I will use this water to clean up. Okay. Okay. Did you all see it? Okay. So now we're going to achieve two things at a time. We clean off the surface of the solar panel, and number two, the temperature that this solar panel absorbs has reduced. So which means its performance will what? Increase. Okay. So we're going to run a test again. What are we getting? Completed. Okay. 2.4. Of course. Look at the time. This is to 6, quarter to 6. Of course, the sun is going almost to what? to where it will set. So that is why the current, all the parameters will be what? Reducing. All right. So now we have all seen that dust that can lead to what? Reduction of the performance of solar system. Okay. For the shading, we are going to use a carton to what? To dissolve these solar collectors to see whether it is real or not. All right. So look up. I connected all the cables without running the test. All right. 0 0, right? So I'm now going to run the test. What are we having? Okay, 2.4, right? So I'm now going to block this to give we casted a shadow. I place this carton here, and then we have small shadow here. Okay, we are going to run another test. It's not sensing anything. Do you know why? Because it is trying to grab the current, but it is not seeing anything. Okay, for the IMP, it was able to what? To get 0.5, but for the ISC 0.000. Even if I allow it to continue, the current will not be as maximum as possible. Why? Because I am blocking a cell. I have already told you, blocking a cell leads to reduction of 25% of whatever the panel is generating. And now I blocked how many cells? Here, vertically, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You see, 12 panels have already been blocked. Now, okay, are you seeing? Okay, it will keep increasing because I removed the barriers. So now the current will be what? Increasing. Now, do you see it? Do you see it now? Just because we removed the carton, the current has increased. So now this is just to tell you these factors really affect the performance of solar system. So now, when we are going to mount our solar panel, make sure that first thing, where is your location? Where are you located? It matters. Like here, we are in Kazana State, we are in the northern hemisphere. So as such, the angle of inclination is somewhere around 13 degrees, maximum of 15 degrees to take for the worst months of the year, all right? And then the orientation is supposed to be southwestern orientation. Now we have many ways of what? Collecting solar intensity. We have what we call solar tracker. And in case, if we don't have capacity to go for solar tracker, we can place our solar panel in the what? Eastern and western orientation, east-west orientation, so that in the daytime when the sun is rising, it will be sending the current or the light to this solar collector, and then anything from, let's say, 12:1, which means this will be collecting scattered and reflected, whereas the one facing the western orientation will be what? Will be getting all the three radiation: direct radiation, reflected radiation, and diffuse radiation. So basically, we are going to attain a better performance. Thank you very much. See you in our next class so that we'll discuss on the other components. See you next. So now we are moving to the configuration of solar panel. What are they? Series. What is series connection? Parallel. What is parallel connection? Series, parallel. In our next class, this is what we are going to discuss extensively. See you. Don't miss out. Thank you very much.